Welcome back to the workshop. We want to take another look at an example of evaluating a limit at a real number. So we want to evaluate our limit, prove the result, and the limit of interest in this case is the limit as x approaches 0 of sine of x over x. This is a familiar limit to us, and we should already be aware that the limit is 1. If you want a justification or an explanation, the best I can give you is actually the proof that I'm going to show you now. So, for our proof, we're actually going to use the squeeze theorem for limits. So we want to consider the unit circle. So we'll begin with the unit circle. And what we're going to be talking about in this case is actually some angle theta. And that's going to be our x value, right? Because we evaluate trigonometric functions at an angle. So we've got several triangles here. One of the triangles is the triangle that we usually consider, and with a length of 1 here, because it's the unit circle, we know that this side length is cosine, and we know this side length is sine. Okay? We're going to need that. We also want to consider the triangle. In fact, we really don't even want that triangle at all. We want to consider the triangle which connects this point, where this line, this ray intersects the unit circle, and this point here, where the circle intersects the x-axis. So we've got that triangle that we want to consider. We also want to consider the triangle where we have the vertical line at x equals 1 with this same edge. And then we're actually going to consider this area here of the sector. Okay, so that gives us 3 areas. All right. And what we want to notice is that we have the largest area with this side length is 1 and this is theta. If we wanted to scale this small triangle up to that large one, we would take this side length of length cosine, and we would divide it by cosine, so that way it has side length 1. So cosine divided by cosine is 1, and sine divided by cosine, to expand this, okay, dividing by a number smaller than 1 makes it larger. Sine divided by cosine gives us tangent. This is actually the tangent of theta. And the area of this triangle would be, let's see here, 1/2 base times height. So 1/2 base times height. And then we would have the next smallest triangle, so that's the area of the sector there. So the sector, this may take a little bit of reaching back for us. The area of the sector is 1/2 of the angle measure times the radius. 1/2 of the angle measure times the radius. So in this case, the radius is 1, so the area is 1/2 of the angle measure times the radius. And then we would have last the triangle generated by connecting these 2 points. So let's get a little bit better representation of that here. There we go. Except not curved, it's straight. There we go. Largest to smallest area. This height here, the height of our triangle, is exactly sine of theta, because that is the height here, sine of theta. So base of length 1, height of sine theta, so this is 1/2 sine of theta. All right, so we have these three areas. This was the largest triangle. This was the small middle area, which is larger than that one. So they're connected by inequalities. So now let's multiply by 2 to get rid of the 1/2 in each case. And let's also divide by sine. So 2 times 1 over sine of theta, because there's a factor of sine here and a factor of sine here, and we want to get sine in the middle as well. So this gives us, the 1/2 is gone, so this is 1 over cosine of theta is greater than or equal to, let's see here, theta divided by sine of theta, which is larger than or equal to 1/2. Let's see here. 1/2. Sorry, 1/2 went away. Sine went away. That's greater than 1. Thoughts rolling through my head here, making sure that we can justify keeping the same inequality. And we can in fact keep that same inequality. Sine is the length of the opposite side, which could be negative in terms of the y value, but when we're talking about lengths, it's always going to be positive. So thinking of it as areas, there's no issue with that there. So we should be okay with that. Once we're here, it will certainly, we don't have any issues because cosine is an even function. So whether we're plugging in a negative number or positive number, we'd end up with the same thing. And then here, sine is an odd function, so when we plug in a negative, that pulls a negative out front, but then we have a negative because the theta is negative. So everything works out well here in order for us to take the reciprocal. And switch signs. If this number is larger than 1 and I take the reciprocal, I'm going to end up with something that's less than 1. Since this is also larger than 1, but it's larger than that, when I take the reciprocal, it's going to be even less than that. So I end up with cosine of theta is less than or equal to sine of theta divided by theta, which is less than or equal to 1. Now, the limit as theta goes to 0 of cosine is exactly 1. So since the limit as theta goes to 0, theta goes to 0 of cosine of theta is equal to 1, the squeeze theorem tells us that the limit as x goes to 0 of sine of x over x is also equal to 1. Okay, this value is 1, that value is 1. Squeeze theorem says that this must be 1. And that's what we wanted to show. So it is the end of our proof. All right, one more example to take a look at. See you guys in just a minute.